let's see how you did. Just make sure you keep practicing, get better at it, because it's not going anywhere, right? Like we're writing our test, but then from time to time, I will keep reviewing this and it'll show up on tests in various ways. So make sure you stay on top of it. Anyways, the fencing company is wanting to sign a contract with a potential client. The fence will be no longer than 150 feet. So that right there, right, it's an indication that there should be some kind of inequality with that one. So I'm going to write down, like this is my first one here. I keep reading. Narrow boards are 6 inches wide. Wide boards are 9 inches wide. There is no inequality there. Yeah. Yes, I will do that in a bit. There must be no more than 90 narrow boards. Oh, okay. No more than 90 narrow boards. Look at all my highlighters. And no fewer than 100 wide boards. So those are actually specific to each maybe variable. We don't know yet. Narrow boards cost this much, and wide boards cost that much. No inequality there. Okay. Define the variable, state the implicit constraint. So X should be number of, which one did we go with first? I'm going to go with narrow boards, number of wide boards. So if you flip this, it's never going to cost you marks. Your graph is just going to look different, but everything else will be the same. Your POIs will be the same, like flipped, of course. Like your POIs will be the exact same numbers, just flipped, because everything is opposite for you, right? But you don't lose marks. So there's our implicit. So you get 1 mark for that. Hopefully you got that one. This wasn't as obvious, right? A company has 2 boards, narrow and wide. Like it wasn't like that. So I kind of wanted you to think a little bit. Develop system of inequality. So let's tackle the no longer than 150 feet. So some of you right away said, well, I need to convert 150 feet. I'm going to say that 1 foot has 12 inches. No way, this is chapter 8. Yes, it is. Sneaked it in there, right? So it's 1800 inches. So anyways, either you use 150 feet or the inches, but I'm going to use inches. So that number should be there somewhere. That number should be there, or the 150 feet, whatever you choose. But it says no longer than that. So my fence, right, will be less than that. So I'm kind of going backwards. And I know that that's where the fact comes in, right? It's 6 inches for a narrow board and 9 inches for a wide board, right? So inches, 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 right? So max 150 feet, which is 1800 inches. Okay, so that's what that is taking care of. And then next, so this makes sense. Number of small boards, number of big boards, right? So the number of narrow boards has to be less than or equal to 90. No more than 90 boards, it says, right? So that, and then the wide boards, it says no fewer than 100 wide boards. I don't know if you recall, but no fewer means, right, it has to be greater than or equal to 100. Would that make sense? No fewer, can't have less, right? It has to be 100 or more. So there are my 3 inequalities. So 3 marks, of course, if you have each one of them appear the same way. If the inequality is pointing the wrong way, if it's one of these here, I would take off a full mark, okay, if it's one of these. If this one is pointing the wrong way, I'd still give you half a mark because you have provided all the other ones are the same. If you chose to convert the individual boards, this should have been half a foot, and this would have been 3/4 of a foot, right? So you can do that as well if you want.
This is the instruction again, teachers. At this time, we need the following grade 10 students to go to room 57.
Okay.
Elwood
I'm going to do this.
Johan Rivera, Lakshay Sharma, Derwin Ubasa, Sukman Kara, Shana Garcia, Renzo Capacia, Mikhail Karam, Sergi Villaforte, Eric Easter, Maverick Aguilar, Chantel Crisamato, Jasrup Singh, Clayton Capistrano, and Alvin Lee. To room 57, Mr. Leduc's room at this time. Thank you.
As I was saying, these are your x and y intercepts, right? Regardless of if you converted everything to feet or inches, you get the same intercepts. That should be clear, okay? And so I'm just going to rewrite it. So 9y is less than or equal to negative 6x. Please don't forget that, right? When the 6x comes over, right, it changes sign. Plus, we have that 1800 there. Divide everything by 9. Y is less than or equal to negative 6 over 9. That's negative 2/3. If you notice that, great. If not, no big deal. That's solid. True is below. I will shade above. And I used up a lot of space there. So if that ever happens to you, use the space up here, all around it. It's fine. This one is easy, right? This is solid. True is to the left because it's x, it's vertical, right? I'm going to shade to the right. Solid, true is above. I'm going to shade below. Yep.
You can get full marks if you decrease the slope from 6 over 9 to 2 over 3.
Yeah, you get full marks. The only time you will lose marks if you don't do it correctly, like if you reduce incorrectly. So you can just leave it. You can do it whatever you feel more comfortable with. So I'm still wanting to get to the most important part, number of narrow boards. I would love it if nobody would lose any marks here because of that. Okay, just get that over with. I'm looking at my intercepts. 300 will definitely do. So if you want to go 100, spread it out. Right? Don't compact every. So 100, 200, 300, 400. So every tick represents a 100. Sometimes some students like to split that up, right? You split everything in half. Those are your 50s, not a big deal, right? And then you go up here, 200 will do. So I'm going to go 100, 200, 300, and for good measure, 400, right? But don't go like to 1,000, right? That's too much already. Like 200, 300 will do. I should have probably, you know what? I'll just show you that it's probably better to just go 100 here, 200, because I'm not going higher than that. Yeah, I'm just going to leave it like that. So I have more room. If the solution region is like a thin little sliver, this will make it more apparent if you make your scale appropriate to the situation. So 300, 0 is here. 0, 200 is right up there. I don't have a ruler. I do have a ruler. I rented mine out for now. So there it is. Right, that's the first one. And if you didn't get this, just make sure you learn from it, okay? That's all good. And then we have our 100 line, that's the horizontal. Y is greater than or equal to 100. And the vertical, which is 90. This is 100 for me, so 90 is just shy of 100. No, sorry, 90 there. Okay, so we have that, and now the shading part begins. So I'm just going to go back a shade to the right of this. Watching 2.5 speed. There. And then the horizontal is below. There will be a solution, guys. I will not will not lie to you on that. Like, you will have a solution region, right? So if you graph this and you don't, maybe go back, right, and check. The most obvious, I would say, is when you have, like, you scale everything and then you have this tiny little line here, something like that, right? And everything is like way out there and it's not, doesn't make sense. That's usually an indication that you probably forgot about the 6 and the 9 or one of the coefficients, right? Or you didn't convert, okay? So my solution region, I need to label that, is right there. I have 1, 2, 3, 4 corner points. And those I will label up here. POIs. I know this one is 0, 100. I know that one is 0, 200. This one here I know as well, right? It's where the 90 meets the 100. You could use your calculator for it, but you don't really need to. And so that leaves me with this one. So let's go ahead and enter that. I'm just going to enter the diagonal, which is this one here, -6/9. If you didn't get this, it's probably good practice to just do this anyways. And then the other one is that vertical, which is x minus 90. And I'm going to go my window. I'm going to go out to, you don't have to, but I'm going to go 400. And this, I'm going to go to at least 200 or 250 on the Y max. Remember, Y min, you need to see quite a bit so that it's not blocking. So I'm going to go minus 100, something like that. I'm going to graph it. There it is. That's the one I need to find, right between this diagonal and the vertical right here. So I don't bother entering the other ones in this case.
Apologize for the other interruption with the grade 11th at this time. Please report to Mr. Leduc's room, room 57. Eileen Sarn, Carl Papa, Colin DeLeon, Julia Maliga, Sydney Pacheco, Sarah Neil McSwain, Maribel Jelani, Sobot Gill, Jonah Policarpi.
Half a mark. So if lines are not labeled, even if one is not labeled, half a mark deduction. If your scale is off, half a mark deduction. If you didn't label your axes, half a mark deduction. So that's how I would do it. Yeah.
When you say your scale's off,
So sometimes I have students going 50, 150, like it's not consistent. So it has to be going up by the same amount, and the space has to be the same. If I see that you're going like 100, all of a sudden 200, like this space is not the same as that, right? So I'm looking for consistency. Marks wise, so I talked about this being 3, right? 1 for each. I would give you 1 mark for the intercepts of the diagonal line, and I would give you 1 more mark for rewriting it. So this 3 is going to change in a bit. So just make sure you follow this. 1 mark for the intercepts, 1 mark for rewriting. I would give you together here 1 mark for identifying where to shade on the vertical and horizontal. And then you following that, that's 3 marks, right? And then keep going. I would give you 2 marks for the graph alone, because they're pretty easy to graph, these ones, okay? So 2 marks for all the components that belong to it, including the solution region labeled. I would give you 2 marks in total for this. So let's just say half a mark for each correct corner point, just to make things easier. So you can get rid of this 3 here and just say, watch, 1, 2, 3, 4, 5, 6, 7, right? So this whole area in the graphing section would be worth 7. I like to rather give full marks for steps instead of half, because half is, I don't know. I'd rather a test be worth 50 marks and have 1 mark for most things than 25 marks and give half marks. Yeah.
How many marks
Is which?
How many marks?
Question B, this is out of 3 here. If you just look at writing the inequalities, this one you got to move away for now, just 3, 1 for each correct inequality. So this 3 here stands, right? So 1, 3, C is worth 7. You're amazing. The one thing that I appreciate every time I give you an AC, you're going to town, right? You're doing this. You're working, right? You're not just like, I can't do this, right? So that's a very good thing. Don't give up on that. If you do that in life, you'll be successful, okay? If you keep going at it. State the objective function that determines the total cost, okay? We're talking total cost. So I'm going to go C would be, that's when you go up, and at first there was too much information, right? 350 and 430 per board. Yeah, right, with the prices nowadays, it's way more than that. But anyways, 350x plus 430y. You get a full mark for that. 1 full mark for that. Oh, hold on. I always forget this because to me, you know, it's common sense. But all of my points were whole numbers, correct? So this is discrete data though, because it's number of boards. So if you had a decimal here, you would have to round it, right? In this case, and we don't need to do that. Everything worked out just fine. Just keep that in mind, okay? Almost done here. Which combination would result in the least expensive project? So that's like figuring out the minimum, like the minimum cost. So this is how I will allow you to do this, okay? This is technically a function. You can do this. C of 0, 100. You're plugging in these coordinates. That would be, if you plug that into this, you can have your calculator next to you. This is 0, so you just go 430 times y, which is 100, right? So that's 430 would be the cost under this first scenario. Okay? And then you go cost of 0, 200. Of course, that would be 860. It's double, right? It's double the previous amount. The cost of getting 90 narrow and 100 wide boards, you got to go 350 times 90 plus 430 times 100, and that's 745. Okay, so you write that down, and you probably already guessed that this is going to be it, right? And then you have your last point, which is 90, 140. It's seriously. It's happening today.
This is the final call. Grade 12 at this time. If your name is called, please go to room 57, Mr. Ledger's room at this time.
Okay.
Bill Panez, Kimberly Chow, Cassandra Danilau, Thomas Haggis, Timmy Wang, Pete Lumba, Anthony Campbell, Kurt Barjadian, Felicity Ann Malone, Sierra Cantino, Francesca Marie Musni, Michaela Deleg, Ina Guerra, Justine Mendoza, and Francesca Reyes to room 57. Thank you.
There it is. So you plug every single corner point into that function. You don't need to show everything because I know it's a lot of work. Just plug it into the, right? Like if you give in the x and the y, plug it in, see what you get. using only 100 wide boards is going to be the combination that results in the least expensive project. Yeah. You didn't do this? This part? Half off. Did you circle at least? Which one is? Yeah, then it's only half off. Yeah. So if you like the half mark and you like to write, you get 100%, right? If you write it down. And the reason being is the curriculum guide. This is a very exciting document to read for bedtime reading. We teachers, we need to read it, right? So it tells us that they want you to identify what does that point actually mean, and this is what it means. So fortunately, I can't get away from that. Backside, 149. I still have time. All right. So watch this. Read carefully. Assume regular shading has been used. That means that for this line, this is true. And for this line, this is the true region, right? Because we've been shading the true regions, okay? So for line A, let's figure that out. My intercept is 3, right? And what is my slope? Anybody figured that out? I'm thinking right here. So that's 1, 2, 1, 2, 3, 4, 5. And it's going down, right? So it's going to be y is, sorry, about down here, is greater than or equal to negative 2 over 5x plus 3. And then for line B, true is below, right? So I'm going to go below just like that. Not the equal sign because it's dashed. And my intercept is negative 1, right? This is negative 1. But I need to figure out my slope. So I scan it, and right here is where it goes right across. So 1, 2, 3, 1, 2, 3, 4. Rise of 3, run of 4. And it's positive. So that's 3 over 4x minus the intercept, which is 1, right? So you get 1.5 for each. If you make any mistake, just take off half for that mistake, okay? Okay, the last one I'm going to show you here. We still have a little bit of time. I would like to do at least one so that if it's on the test, you can't say we didn't do this a couple of times. Okay, so it's x minus y. Watch the sign, okay, everybody? X minus y. So I go 10 minus y happens to be, right? This is x, this is y. So I'm following this. That's supposed to be greater than or equal to 17. 10, negative and negative, turn positive. This is 25. And so check, that does pass the test, right? 25 is definitely greater than 17. Then I'm going to try it with the second one. 2 times x plus 5 times y is supposed to be less than or equal to negative 20. 2 times 10 is 20. 5 times negative 15 is negative 75. Yeah, there we go. I knew that. Thank you, Jeremy. Negative 45 minus is that. Is this true? Yeah, this is more negative than this one, isn't it? Right. So this is smaller, so that's true as well. Therefore, as I was saying, negative 55. Thank you, Jeremy. Sheesh, like, is it Monday or Friday? Therefore, 10, negative 15 is a solution. Yeah, good job, Jeremy. Saving the day twice. We're good?